I welcome you to this chemistry paper, or let me say science paper 2. So in this video, we are going to look at organic chemistry. So as chemistry is concerned, organic chemistry is going to come in your paper. This one is highly examinable. Whichever paper you are going to take, you are going to find questions from organic chemistry. So as for organic chemistry, it is just a branch of chemistry that deals with what? The study of the compound of carbons, except oxides and carbonates. So in this case here, whenever you find compound containing carbon dioxide, except carbonates and oxide, like carbon dioxide, those are not what? Organic compounds. Okay, so as for organic compounds, they contain only two compounds. They can contain carbon itself and also hydrogen itself. Okay, so now on this part here, we have different hydrocarbons. So the first one being is the alkanes. The first one being is the alkanes. Then the last one is the alkenes. Okay, so the question is saying the alkenes are a homologous series of hydrocarbons. So the term hydrocarbons means that the compounds that contains hydrogen and carbon atom only. So hydrocarbons are compounds that contains hydrogen and carbon atom only. Okay, so this one here it is saying alkanes. So as for alkanes, these are saturated hydrocarbons. When you say saturated hydrocarbons, as you all know that carbon dioxide, it has a valence of 4. So since carbon it has a valence of 4, which means it can allow or it can be bonded to 4 atoms only. Okay, so now when you say alkanes are saturated hydrocarbons, which means all the sites or all the bonds on the carbon atom are surrounded by what? Atoms. Specifically here we are talking of hydrocarbons, which means all the bonds are surrounded by what? Hydrogen atoms. Like for example, the question in B. Okay, so the first question, which is question A, is saying give the general formula for the alkanes. Give the general formula for the alkanes. So if they ask you to give them the general formula for the alkanes, for this one here, since alkanes are saturated hydrocarbons, so I'm going to say CN, I'm going to say CnH2n plus 2. I'm saying CnH2n plus 2. That one is the what? The general formula for the alkanes or alkanes. If you want to find any alkane, you need to use this general formula. So now, since here I'm saying CnH2n plus 2, where N is going to represent the number of carbon atoms. N is representing the what? The number of carbon atoms. So in this case here, I'm going to give you the prefix. Okay, I'm going to give you the what? The prefix. Since this one here, it is we are talking of the alkanes. Alkanes, they end in A-N-E. Okay, so whenever you see a compound ending in A-N-E, which means that one is going to be what? An alkane. Okay, so whenever you see a compound ending in what? A-N-E, that one is the what? The suffix. Okay, the suffix of alkanes. So all alkanes, they end in A-N-E. For example, they can say butane or propane or ethane or methane. So those are examples of what? Compounds that are falling under what? Alkanes. Now I was saying, let me give you the prefix that is going to help you to remember all these. Okay, so the prefix goes like this. Okay, so we have the first one, which is the meth. So meth is a prefix. Meth is a what? A prefix. So now whenever you hear the word meth, which means the number of carbon atoms is going to be what? 1. In this case here, the value of N is going to be what? 1. Okay. Then we also have ETH. So ETH represents what? 2 carbon atoms. ETH represents what? 2 carbon atoms. So in this case here, since we are talking about alkanes, so as for the first one, which is meth, it is going to be what? Methane. Okay. So which means it is going to contain 1 carbon atom, then 4 hydrogen atoms. Okay. Followed by prop. So prop, which means it contains what? 3 carbon atoms. 3 carbon atoms. Then but. But, which means it contains what? 4 carbon atoms. So in talk of but, if you are talking of alkanes, so but is going to be what? Butane. Okay. So I was saying, as for all alkanes, they end in a suffix of what? A-N-E, which means when you talk of but, which means it's going to be what? Butane. Okay. Butane. But the number of carbon atoms, they are going to be what? 4. Then followed by pent. Pent, it is having what? 5 carbon atoms. Then eggs, it is having what? 6, ept, 7, oct, 8, nano or nonam, which is what? 9. And then deca, we have 10. Okay. So that one is was just a prefix, which is going to help you to remember all those. Okay. So question B is saying the structure of one isomer of an alkane is shown. So now when you talk of isomers, these are organic compounds having same molecular formula but different structural formula. So as for this one here, if they are going to ask us to draw another isomer for this one here, I'm going to show you how to draw it. So as for this one here, as you can see, it is having how many carbons? It is having 4 carbon atoms. Then here I was saying, as for but means 4 carbon atoms. Now this one here, we are talking of alkanes. Then alkanes, they end in a suffix of ane. So this one is going to be what? Butane. Okay. So name the alkane. So I'm going to say this alkane, it is what? Butane. Okay. Butane. Then as for Roman numeral number 2, is saying draw the structure of a different isomer of this alkane. Show all of the atoms and all of the bonds. Okay. So when you talk of isomers, these are organic compounds which have same molecular formula. So in this case here, as for butane, it is going to have what? C4H10. C4H10. So in this case here, they are going to share the same molecular formula, but the structure is going to be different. So in this case here, we are going to break one bond here. Okay. So it is going to look like C. Then between okay. So here we are having what? We are having 3 carbon atoms. Now, in between 3 carbon atoms here, we are going to break a bond here. So I'm going to say CC. Then down here, I'm going to put what? Another carbon atom. So when you talk of isomers, the instance here is that we are not supposed to rewrite the same structure formula like that one in what? B. We need to draw the different one apart from this one here, the different one. So in this case here, we are going to break one bond here. Then the structure is going to look like this. So I'm going to get what? C with hydrogen atoms. Now remember, the carbon atom can only bond to 4 atoms, or it has 4 bonds where the atoms can be bonded. So in this case here, if we break one carbon chain here, we are going to find that it is going to look like this. Okay. So in this case here, the next one is saying the fractional discretion of petroleum the fractional distillation of petroleum, crude oil, produces fractions containing alkanes of different chain length, which means when they talk of different chain length, which means not all the alkanes which are going to be produced, or if an alkane undergoes what? Fractional distillation, you are going to find that different fractions are going to be produced. Now, those fractions are going to differ in terms of the number of carbons. So the instance here is that when a compound is having more carbon atoms, it is going to have what? High melting point and boiling point. For example, if you talk of butane, the same structure in question B, butane, and also we take ethane. Ethane is having what? 2 carbon atoms, which means as for butane is going to have what? High melting point and boiling point compared to what? Ethane, since ethane is having what? 2 carbon atoms. Now the question is saying separation by fractional distillation depends on a physical property of the fractions. Name the physical property. Okay, so the fractions, they depend on the number of carbon atoms. They depend on the what? The number of carbon atoms. So as the number of carbon atoms increases, the temperature also increases. But if the number of carbons are reducing, also the temperature or the melting point and the boiling point is going to be what? Reduced. Then as for Roman numeral number 2 is saying naphtha is one fraction separated from petroleum, which is crude oil. State the main use of naphtha. So naphtha is used in chemical manufacturing what? Industries. Naphtha is used in what? Chemical manufacturing industries. Okay, so let's move on to the next one. So the next one is saying the alkanes, let me say the alkenes. So here we are talking about alkanes. So the next one is for alkenes. So the alkenes are a homologous series of hydrocarbons. So when you talk of hydrocarbons, these are organic compounds that contains the hydrogen and the carbon atom only, or carbon atoms only. So the first one is saying, which is question A, give the general formula for the alkenes. Give the general formula for alkenes. So in this case here, I'm going to say the general formula for alkenes is CnH2n. That's all. Okay, CnH2n. That's all. Now, where N is going to represent the number of carbon atoms. So in this case here, I forgot to tell you that alkanes, they are saturated hydrocarbons. Alkanes, they are saturated hydrocarbons. When you say alkanes are saturated hydrocarbons, which means they have a single bond in between them. They have a what? A single bond. Okay. They have a what? A single bond between them. Now, as for alkenes, they are unsaturated hydrocarbons because they contain a double bond, like the structure which is on question B. Okay. So question B is saying the structure of an alkene is shown. The structure of an alkene is shown. Now, for us to know this one here, the first question, which is Roman numeral number 1, is saying, name this alkene. So now, for us to know this alkene, we are going to count the number of carbon atoms that this one has. Okay, so we have 4 carbon atoms, which means I have given you a prefix, which is saying meth contains 1 carbon atom, eth contains 2 carbon atoms, prop contains 3 carbon atoms, and then but contains what? 4 carbon atoms. Now on this part here, all alkenes, they end in a suffix of what? E-N-E. Okay, E-N-E. So since this one here, it is containing what? 4 carbon atoms. I'm going to say this one is what? But. Now, we are talking of alkenes, so which means this one here is going to what? Butene. Okay, so then the name of this alkene is what? Butene. Okay. Then the next one is Roman numeral number 2 is saying, explain how this structure shows that alkenes are unsaturated what? Hydrocarbons. So the reason here I'm going to say because it has a what? A double bond. Because unsaturated hydrocarbons, they have a what? A double bond. Then the next one is saying hydrocarbons. The reason why this alkene is called hydrocarbons because it contains carbon atoms or hydrogen and carbon atoms only. Hydrogen and carbon atoms only. Hydrocarbons. Hydro coming from hydrogen. Then carbon coming from where? From carbon. So because it contains what? Hydrogen and carbon atoms only. Then question C is saying alkenes are produced by cracking. By cracking some fractions obtained from fractional distillation of petroleum. State the meaning of the term cracking. So when you talk of cracking, this is just the process by which alkanes are subjected to a catalyst or high temperatures in order to produce what? An alkene and an alkane. Okay, so this reaction, it's a type of reaction or the reaction where alkenes are broken down to form what? An alkane and an alkene. Okay, so the process which involves the breaking down of an alkane to produce an alkane and an alkene. So during cracking, two products are produced. During what? Cracking, two products are produced. An alkane and an alkene. Okay, but this reaction, it is unpredictable. Okay, so as for D is saying carbon monoxide is formed when alkenes undergoes incomplete combustion. State one effect of carbon monoxide on health. Okay, so carbon monoxide causes what? Lungs cancer. Carbon monoxide causes what? Lungs cancer. Now this question here, it was talking about combustion of alkenes. So now what you need to understand here is that general combustion or complete combustion. Complete what? Combustion. When an alkene undergoes what? Complete combustion, the products that is going to be produced is what? Water and carbon dioxide only. That is for what? Complete combustion. When you combat or you burn alkanes or an alkene in air, you're going to find that two products are going to be produced. That is what? Carbon dioxide and water. Apart from that one, also if alcohols undergoes what? Combustion. Let's say, for example, if you talk of complete combustion, the products that are going to be produced is what? Carbon dioxide plus what? Carbon dioxide plus what? Water. Now, if it is an incomplete combustion or incomplete combustion, two products also are going to be produced. That is what? Carbon monoxide and water. Okay, so let's move on to the next one. The next one is saying petroleum is a mixture of hydrocarbons. In an oil refining, it is separated into fractions by fractional distillation. The diagram shows a fracting column and some of the fractions obtained from petroleum. Okay, so we have refined petroleum gas, naphtha, paraffin, also called kerosene, butane or butane. Okay. Apart from that one, you also have the ether, and also crude oil. So crude oil is an alkane. Okay. So the first question is saying, which is question A, state the physical property on which the separation depends. So they depends on the temperature. They depends on where? On the temperature and the number of carbon atoms. The compound is going to contain more carbon atoms. It is going to be separated at the end. Okay. What I mean here is like this. If a compound is containing many carbon atoms or large number of carbon atoms, which means that one is going to have what? High melting point and boiling point. For example, if you talk of butane and ethane, butane is going to be separated at the end, okay? Because it contains what? More carbon atoms compared to what? Ethane, okay? So the higher the more the number of carbon atoms increases, the more the melting point and the boiling point increases. Okay. Then as for B, Roman numeral number 1 is saying, state one use for naphtha fraction. So naphtha is used in where? In chemical manufacturing industries. Specifically, it is used in where? In manufacturing of pesticides. Okay. Apart from that one, we also have Roman numeral number 2, which is saying, state one use of butamen. Okay. So butamen fraction. So butamen fraction is used in road making or tar making. Road making. Okay. Then as for C, question C is saying the liquefied petroleum gas fraction contains the saturated hydrocarbons, methane, which is CH4, and ethane, which is C2H8. Then the question is saying, what is the meaning of the term saturated hydrocarbons? The term saturated hydrocarbons means that it means a compound which contains what? A single bond. Okay. Or a compound which contains what? A carbon atom surrounded by what? Hydrogen atoms on all four covalent what? Bond. Since we know that carbon, it can only form about what? 4 bonds. Now, when you talk of saturated hydrocarbons, which means all the bonds on the carbon are surrounded by what? An atom. Specifically, or is surrounded by what? An element. Specifically, we are talking of hydrocarbons, which means all the covalent bonds, they are going to be surrounded by what? Hydrogen. Okay. So, the next one, it is saying, the following diagram shows some of the reactions of ethanol. Okay, so I was saying, when ethanol undergoes what? Combustion or complete combustion. Complete what? Combustion. Or they can say excess oxygen. If excess oxygen is used, which means that one is what? Complete combustion. So when ethanol undergoes complete combustion, 2 products are going to be produced. That is what? Water and carbon dioxide. Now, if ethanol undergoes what? Incomplete combustion, 2 products are going to be produced. The first one is going to be what? Carbon monoxide and water. Okay. So we have the diagram. So this diagram is showing we have solution P. So we have ethanol. Ethanol undergoing what? Oxidation. So if ethanol undergoes what? Oxidation, an acidic solution is going to be produced, okay, which is what? Ethanoic acid, okay, ethanoic what? Acid. When ethanol undergoes what? Oxidation, ethanoic acid is going to be what? Produced, okay. Apart from that one, we have process Q. When ethanol undergoes process Q, which is what? Dehydration. Okay, alcohols, they contain what? The functional group, which is what? OH. Okay, so now once you remove OH, which means alcohols, they are going to undergo what? Dehydration. Dehydration is the removal of what? Water from a compound. As the result, if we remove water from alcohol, we are going to find that ethene is going to be what? Produced. Okay. Then apart from that one, when ethanol undergoes what? Complete combustion, I was saying 2 products are going to be produced. That is what? Carbon dioxide and water. So now in this case here, they have skipped one product, which is what? Gas ara. So now since this one is complete combustion, I'm going to say gas ara is what? Carbon dioxide. Okay. So the first question, which is question A, is saying, draw the structural formula for ethene. Draw the structural formula for ethene. Now ethene is falling under what? Alkenes. It is falling under what? Alkenes. Then alkenes, they have a what? A double bond. Okay, they have a what? A double bond. And usually alkenes, they start from where? From ethene, not from methane or meth. They don't start from where? From meth, because meth contains what? Only 1 carbon atom, which means there will be no double bond if we say meth is falling under alkenes. Okay, so I'm going to say the structural formula is going. Let me say the structural formula for ethene is going to be what? C double bond C. So on the double bond there, we are having what? 2 bonds, which means on each carbon, we are remaining with what? 2 bonds. So I'm going to say H on top and H down. And also on this part here, I'm going to say H on top and H down. Okay. So now let's try to answer the next one. Okay. So the next one, or question B, is saying, give the names for Roman numeral number 1, solution P. So solution P, it is the what? The acidic solution. The acidic what? Solution, which is what? Ethanoic acid. Then as for Roman numeral number 2, process what? Q. As for process Q, I'm going to say dehydration. Okay. Dehydration, the removal of what? Water from a compound. Then as for Roman numeral number 2, I'm going to say gas R. Gas R is called what? Carbon dioxide. Okay. Carbon dioxide. Then as for C, it is saying, write a balanced chemical equation for the complete combustion of ethanol. For the what? Complete combustion of what? Ethanol. So ethanol, it is what? It is C2H5OH. Ethanol is what? C2H5OH. Now here, we are reacting ethanol plus what? Oxygen, because oxygen is supposed to what? Burning. Now, as for oxygen, it is going to have what? O2. Now, here I was saying, when ethanol or alkanes undergoes what? Complete combustion, 2 products are going to be formed. The first one is what? Carbon dioxide plus what? Water. But if they undergo incomplete combustion, 2 products are going also to be produced. That is what? Carbon monoxide and what? Water. So now here they are saying it is complete combustion, which means if we react ethanol plus water, names plus oxygen, carbon dioxide plus water is going to be produced. Okay. Now this equation is not balanced. So I'm going to say if I put 2 on the reactant here for ethanol, I'm going to put 2. Then on the oxygen here, from the same reagent, I'm going to put what? 7. Then on the products for carbon, I'm going to put what? 4. Then as for water, I'm going to put what? 6. So now as you can see here, on the reagent, we have 4 carbon atoms. And also on the products, we have 4 carbon atoms. Then on the under hydrogen, we have on the reagents, hydrogen, we have 12, because 2 multiplied by 5, we are going to get 10. Put 2 multiplied by 1 hydrogen here, we are going to get what? 2. So hydrogens here, we are going to have what? 12. Then on the other side of the products, we are going to get what? 12 also. Then apart from that, on oxygen, we have 14. Let me say we have 14. Yeah, we have 14. Now let me just do this, okay? Because here we have how many hydrogens? Okay, so in part of oxygen, we are not going to put 7. Let's try to put 6. So if we put 6 on the reagent, the oxygen gas, here we are going to find that on the reagents, we are going to have what? 14 oxygens. Then also on part of the products, we are going also to have what? 14 oxygens. So that is the what? The complete chemical or combustion of ethanol. Okay. So the next one is saying ethene, but1-ene and but2-ene are alkenes. Okay. So we have the displayed formulae of ethene and but1-ene are shown in figure 7.1. So we have the first one, which is ethene, then followed by but1-ene. Okay, so but1-ene is same as the normal butane. Okay, is same as what? The normal butane. Okay, so the first question, which is question A, is saying, state the general formula of the homologous series of alkenes. So here I was saying the general molecular formula of alkenes is what? CnH2n, that's so. CnH2n, that's so. Where n is going to represent the what? The number of carbon atoms. So the next one is saying, which is B, but1-ene and but2-ene are structural isomers. State the meaning of the term structural isomers. So structural isomers, these are organic compounds or hydrocarbons which has same general molecular formula or same molecular formula but different what is structural formula. So they are going to have what is same molecular formula but different what is structural formula. That is what is the structural isomers. Structural isomers, these are organic compounds that contains what that have same molecular formula but different structural formula. Then as for Roman numeral number 2 is saying, draw the displayed formula for but2-ene. So as for but2-ene, I'm going to write I'm going to break one bond here. Okay, so I'm going to say C with a double bond here, and then C, another C. Then in between two carbon atoms, I'm going to draw C also down here. So I'm going to break one bond here. Then here I'm going to have what structure like this one here. Okay, so I'm just cutting on one carbon atom here, and then join it at carbon number 2 like this. Okay, now remember on this part here, the carbon which is in between two carbon atoms, we are going to find that here we are having a double bond, then here we are having a single bond, and also here we are having what? A single bond, which means the carbon atom which is in between two carbon atom, it has already have 4 bonds occupied by what? Carbon atoms. So which means here we are going to remain with only these 3 carbon atoms. So as for this one, the first carbon atom, it has 2 bonds here, which means it is only remaining with what? 2 bonds, which means on top here we are going to draw a bond with an hydrogen atom, and also down here we are going to draw a bond with one hydrogen atom. One hydrogen what? Atom. So as for the first one here, we are just going to draw a 2 hydrogen atoms, because here we are having what? A double bond. Then the carbon atom which is in between these 2 carbon atoms, we are not going to put any hydrogen atom, because as we said, carbon atom, it can only have what? It has a valence of 4, which means it can only accept what? 4 bonds only. Okay, so the last one also you need to add 3 hydrogens, and also this carbon atom that we have broken it, we are going to also to put what? 3 hydrogen what? Atoms like this. Okay, so the next one, which is question C, is saying but1-ene is an saturated hydrocarbon. Roman numeral number 1, state why but1-ene is unsaturated unsaturated what? Compound. The reason why this one here it is unsaturated compound, because it contains what? Double bond. That double bond allows the alkenes to undergo a reaction. Okay, so as for alkenes, since alkanes are saturated hydrocarbons, which means the covalent bond of hydrogen, they are occupied by what? Hydrogen atoms, which means for alkanes to undergo the reaction, there must be what? A condition. Now as for the alkenes, since they have a spare bond which is a double bond, which means they can undergo what? A reaction. Then as for Roman numeral number 2 is saying, state why but1-ene is a hydrocarbon, because it contains what? Hydrogen and carbon atoms only. Okay, then the last part of under polymers, the last part under what? Polymers. It is saying proteins and peptides are polymers made by a reaction called condensation polymerization. So as for polymers, these are giant molecules formed by joining small units called what? Monomers. So polymers are giant molecules formed by joining small units called monomers. Okay, so we have the first question, which is question A. It is saying the diagram in figure 10.1 shows the structure of a section on a protein. So now this structure here, it is called what? A protein. Now, for a protein to be formed, a dicarboxylic acid should react with what? Diamine. Okay, so a dicarboxylic acid should react with what? Diamine. So the structure of diamine looks like this. Okay, the structure of diamine looks like this. So as for diamine, it contains what? Nitrogen and hydrogen only. Nitrogen and hydrogen only. Remember, nitrogen has a valence of what? 3, which means this nitrogen can only form what? 3 bonds. Only 3 bonds. That's all. Then hydrogen has what? 1 valence, which means it can only form what? 1 bond. So this one is the what? The structure of diamine. Apart from that one, the structure of what? Dicarboxylic acid. So the structure of dicarboxylic acid looks like this. So the structure of a dicarboxylic acid contains what? Oxygen, a carbon, and the hydrogen. Okay. So now during condensation polymerization, water is given out. Okay. Water is given out during what? Condensation. Water is given what? Out. So now the question, which is Roman numeral number 1, is saying, draw this general structure of the amino acid monomers used to make what? Proteins. We know that the building blocks of proteins are amino acids. So on this part here, we are just going to give them the diamine and also dicarboxylic acid, because when you react diamine and dicarboxylic acid, you are going to get what? Protein. So the structure of dicarboxylic acid looks like this, and also the structure of diamine looks like this. As for diamine, it contains what? Nitrogen atom and also hydrogen atom. And remember, nitrogen, it has a valence of 3, which means it can only form about 3 bonds. Then as for dicarboxylic acid, when you say di means what? 2, which means you are going to have 2 acids. You are going to have what? 2 acids. So the functional group of acids is what? Cu, which is denoted by what? COOH, which is what? Cu. This one is the what? The functional group of what? Carboxylic acid. Then as for Roman numeral number 2, proteins are polymers. Proteins are polymers. So as for polymers, let me also not forget this structure here. This structure here, which is what? NHC double bond O. It is called what? The amine linkage. The amine what? Linkage. NHC double bond O. It is called what? The amine linkage. So now the question is saying proteins are polymers. Proteins are what? Polymers. Name one other polymers. So here I'm going to say nylon. Nylon, it also contains the same structure that you are seeing here on the diagram here. That is the same structure that nylon has or have. Okay. Then as for question B, paint is a polymer used to make plastic bottles. So the diagram in figure 10.2 shows the structure of paint. So now, as you can see here, we are having a linkage, which is OC double bond O. So this linkage is called what? The ester linkage. Okay, the ester what? Linkage. So as for Roman numeral number 2 is saying, name the linkage present in PEPT. So PEPT, it contains what? Ester linkage, as you can see. So the ester linkage is denoted by what? O, C, double bond, then we can say O. Then the last one, which is Roman numeral number 2, is saying, proteins and paint are both made by condensation polymerization. Describe the difference between condensation polymerization and addition polymerization. So now when you talk of condensation polymerization, you're going to find that water is given out. Okay, water is what? Given out. So now, for paint to be formed, a dicarboxylic acid and a dialcohol reacts. So the structure of dialcohol looks like this. Then the structure of dicarboxylic acid looks like this. So you're going to find that the dialcohol is going to give what? 1 hydrogen. Then dicarboxylic acid, which is the what? The acid is going to give what? Is going to give HO or OH to form what? Water. So during condensation, water is given out. During what? Condensation, water is given out. While during addition, polymerization, you're going to find what? The ester, let me say, the polymer is going to be what? Is going to be formed. Only the polymer is going to be what? Formed. Apart from that one, we can say during condensation, during what? Condensation, the saturated hydrocarbons are added. The saturated what? Hydrocarbons are added. So in this part here, when you talk of condensation, polymerization, you can add the alcohol and an acid to produce what? A polymer, and also what? Water is going to be given out. Now when you talk of addition, polymerization, you are going to add what? The identical, when you say identical, which means same, identical unsaturated what? Hydrocarbons. Identical unsaturated what? Hydrocarbons. So now in this case here, the identical unsaturated hydrocarbons, they are called what? Alkenes. So when you say identical, which means for you to produce a polymer under addition polymerization, you need to add the same unsaturated what? Hydrocarbons. For example, if you add ethene plus ethene, that one is going to be considered what? Addition polymerization. So here I was saying, during condensation polymerization, saturated hydrocarbons are used, while during let me say during condensation polymerization, saturated hydrocarbons are used, while during addition polymerization, identical unsaturated hydrocarbons are used. So that was the last one. See you next time. And if you're new to this channel, remember to subscribe for more videos. Thanks for watching.